right, so we're going to go over question 3. Now, question 3 is an equilibrium and a kinetics problem. So the first part, it gives you a reaction, and then it says deduce the equilibrium constant expression. So really, you just need to write out the equation for K. So remember, when you write out expressions for Kc, okay, you need to make sure that everything's in brackets. You need to make sure that you take that concentration to the power of their coefficient, and also never include solids. So you have a container with all 3 gases. Those gases can have a concentration. If you had 3 different liquids, those would also have a concentration. If they were all aqueous, then that would also be fine, but they need to be in the same state of matter, and they all need to have a concentration. Solids do not have concentrations. So Kc is equal to the products. Okay, so it's the product to reactant ratio. That's what K is. And that's going to be to the first because the coefficient is 1, and then CO to the first because its coefficient is 1, and Cl2 because the coefficient is 1. All right, so the second one, and then this would earn you the mark. Yes, you do need to include brackets here. And that's pretty much, it should be a simple mark for this one. So state the effect of an increase in total pressure on the equilibrium constant. Okay, be careful because some people will read this and say, oh, well, if you increase the pressure, then it's going to shift to the product side because you've got less moles. That's not what it's asking. It's asking about K. There should be no impact on K. The only thing that impacts K is going to be your temperature. So no, you would not get any kind of impact if you also wrote that it would shift to the product side. All right, so sketch the potential energy profile for the synthesis of phosgene using the axis. Indicate the enthalpy and the activation energy. Okay, so if you look at the first part right here, you'll see that it's got a delta H that's negative, so it is going to be exothermic. So you need to make sure that your products have less energy than your reactants. So we would have our reactants here, and then activation energy, well, it's always going to go up. You always have to put a minimum amount of energy to make the reaction progress. Now it's going to drop down to wherever the products are. All right, so now from the difference between the reactants and the products, that should be your delta H, which equals 108. So your activation energy should always be from your reactants to the top of the hump. So that's my activation energy right here. And that's what it's looking for. So it gives you 2 marks. So you need to make sure that you include the products are lower than the reactants and that you have the enthalpy marked correctly, okay? So with the actual value, that gets you 1 mark. And then your activation energy is the 2nd mark. Okay, so now it's asking you to draw a new line on this. I should not have erased that. Okay, and now you're going to draw a line to represent what happens if your reaction is now catalyzed. So what should end up happening if you put a catalyst in there? It's going to change your activation energy because essentially it gives it a different mechanism, which requires less energy to start. Now, nothing else will change. So the delta H always stays the same. What does end up changing is your minimum amount of energy. The activation energy should decrease. And then that one was just a simple mark. All right, so the next one has a Boltzmann distribution graph, and it's asking you to draw it if it was at a higher temperature. Now, here's something that I know somebody will do. You have an activation energy. That amount does not shift anywhere. This stays right there. What will end up happening because you've increased your energy is the top part, which represents the average amount of energy, that should be over And then your hump should be more spread out. That's because if you have a higher temperature, you're going to have more variety in the speeds. So it should look something like that. So what ends up happening is your activation energy is still the same point. It's just now you've got more molecules that are at that activation energy. But what you need to do in order to get the mark here is you have to move the curve over. So the top of the curve has to be over more towards the right, and you also have to spread it out more to get the mark. Okay, explain why an increase in temperature increases the rate of the reaction. So you get 2 marks for this. So the first mark needs to be, well, one of them needs to be that you have more molecules at the minimum energy. Okay, so you've got more molecules at the activation energy, so that means that you'll have more successful collisions. Now, remember, the rate increases anytime that you can increase successful collisions. Well, the second mark comes from the fact that there now will be more collisions in general. And that's because you've got more kinetic energy, so they're going to be colliding with each other more often. So that's how you get 2 marks. So one of these would have given you 1 mark, but you need both of them to get 2.